Hi, this is Wallace from Capturing Reality, and in this tutorial I'm going to show you how you can download data from the Mars rover and process that data in RealityCapture and make your own models of Mars. You can find a link in the description of the video to all of the scripts used in the tutorial, and also another link to the dataset with a PPI license. The first script we have here is download images. I'm just going to right click it and show you what's going on here. So these scripts are all written in Python. So obviously you need to install Python, and also you will need to install a few modules. For instance, in this script you need to install requests and Beautiful Soup. Now, if you're unfamiliar with Python, you'll just have to Google how to install Python and how to install modules. So when we run this script, it's going to go to this URL and download all the images there. As you can see, the sole number is here, 466, and we happen to know that this is an interesting one with lots of data from the mast cams. But if you discover that you find another sole where there's some good data on the mast cams, you can just change the sole number here and it will download all of those images instead, or any URL from the Jet Propulsion Lab. So let's run this script. Just double click it, and it might take a little while, but in a second you will see that it starts downloading the images. And once that script has finished running, you're going to have a new folder here called Images. And in there, you're going to have all the images downloaded in IMG format. And next to that, each image, you will have an XML file, which I'll just open up. And you can see in here, there's a whole host of information about that specific image. I won't be using any of this data in this workflow, but for more advanced users, you might be able to use it in some way or another. So now we're ready to run the next script. And the next one is called Prepare Geometry Texture Images. I'll just open that one up. And you can see you need to import a few more modules. And this one is just going to read those image files and it's going to save them as JPEGs. We're going to have a geometry folder and a texture folder, and both will be processed in different ways. So let's just run that. And once that's finished running, you're going to have two new folders, geometry and texture. In geometry, you can see we've got lots of local contrast. This helps RealityCapture find features. Normally, I wouldn't do this as extreme as the script has done it. It'd be a lot more subtle, but this actually works. And in the texture folder, we tried to keep the colors as natural as possible. Now, what I'm going to do now is make some labels for the sky. And because this is a very unusual data set, for some reason the sky has been meshing. So we're going to make some labels, and once the sky is labeled, we can select it easily to delete those triangles in the sky. So I'll make two new folders. New folder 1, I'm going to call this for labels. And another new folder where we're actually going to end up putting the labels, it's going to be called underscore labels. Okay, so we'll go into the texture folder, and now I will select every image with a bit of sky in it to copy into the for labels folder. I'll copy those and put them in the for labels folder there, just paste them in there. And now we'll go into Photoshop and we're going to make a new action. So Windows, Actions, and then click here and go to New Action and call it whatever you like. I'm going to call it Sky Labels. And if you press return, it automatically starts recording. I'm just going to turn it off for a second because otherwise it will open the same image every time. So I'm just going to open my image to record the action on, any of the sky ones, and then open it up, and then you can start recording. So edit, select, and then sky, and the AI will do quite a good job of finding the sky there. And what I'm going to do is expand that, so select, modify, and expand, and I'll expand it by 10 pixels. This way we can make sure we're definitely getting all of the triangles in the sky. And I'll fill that with white, edit, fill, and then white, and then select, invert the selection, and then edit, fill, and black. Okay, you could actually use any colors you wanted really. I'm gonna deselect everything and go to image, adjustments, and threshold, and that will make every pixel either black or white. Otherwise we'll get labels for all of those shades in between. And that's ready to be saved as a label in that labels folder that we made. So file, export, and then save for web legacy. And save for web legacy has this type of PNG, so PNG 8 with using selective and then 2 colors. So again, this will make every pixel either black or white. And then save, and then save it into your underscore labels folder. Okay, and that's saved, and then you want to close this as part of the action and don't save it, otherwise you'll go over that image with the black or white image. And that is the whole action recorded. So we can just run that on the whole folder. So we go to File, Automate, Batch, and it should already have the right action loaded in because you just recorded it. And then you choose your folder that it's going to work on. It's already set to 4 labels. You might need to set that, and then OK. And once that's finished running, you can close Photoshop. And if you look here, you'll have a labels folder with a label for every single bit of sky here. So there are a few more things to do before we can open RealityCapture. So we've got one more script to run, edit image metadata. Now if you look at the files, you can see part of the file name here is 110, and that's actually the focal length. So this script takes the focal length out of the file name and also gets the adds the make and model of the camera to the EXIF data of each image. So each image will have the make, model of the camera, and its focal length. So we'll just run that script here. There we go, it's added that EXIF data. And now what we need to do, if I go to the README, you can see that there's a line here we need to add to the camera database. Control C that, and that is the path to the camera database. C, depending on where you've installed RealityCapture, C program data capturing RealityCapture sensors DB. I have that path open here, and there it is. So I'll double click that to edit it. I've already added the line here, but essentially you can add the line just with Control V wherever you like. Oh, I've added it twice, we don't need that, so I'll get rid of one of them. And you can see I've put the sensor width to 9mm. That's actually wrong. The sensor on this camera is actually 11.8mm. But what I found is this is a trick to make the alignment work a little bit better. Don't use it in other projects. Some of the things I do in this tutorial will be very specific to this camera, which only really exists on Mars. So it's not transferable knowledge. So yeah, 9mm basically calculates a longer focal length for the camera, which for some reason, I'm not sure why, gives a better alignment in RealityCapture. So let's save that file, save. And now we can open up RealityCapture. And go to our files, and we want to take in geometry, labels, and texture. And I've got a 2D window open here, so if I click on that and then press tab, you can see the different layers. That's the label layer, and that's the texture layer. And you can see here, if I expand my 1DS, that there we have our focal length, which has been calculated there. And you can see you've got the name and the model of the camera in there. So that's all done. Now, one more thing before we align. If you go to this README file, which will be included with the scripts, I've got this sequence here, so I'm going to copy that, Control C, and then go into RealityCapture, and let's make, we've got a console window here. I'll make this into a 3DS. But in the console here, I'm going to paste in all of that stuff. There we go. And then press the plus here, and then what we're going to call it is group masked cams. You can leave the CMD on the end there. Okay, you can see I've done it before, but now I have a button. If I press it, you can see it is grouping them. I'll just quickly show you the script. Sorry, the command, we go to that README, and there we go. What it is doing, so select image, and then it selects all of the ZLOs, that's all the left cameras, which are 110mm, and it puts them in a lens group and a calibration group the same, and then it selects the right images, which are 110mm, and then puts them in their own lens and calibration group. It actually also goes through other focal lengths like 34mm. We don't actually have any of those images there, but it may as well run it just in case you do use different data sets. You can group those calibrations as well. So I've run that, and if I click on one of these and then go to prior calibration, you can see it's in calibration group 0. -1 is actually not in a group, so that is in a group. And if I go to any of the ones on the right cameras, you can see they're in calibration group 1. So we are almost ready to align, but first let's change the alignment settings. We go to the settings and advanced, and let's change the distortion model to division. This actually works quite well when you just leave it on the default of brown 3, but I've had more consistent results using division. And let's change the image overlap to low. Again, don't try this on other data sets. Generally the defaults are a lot better, but this is quite unusual data, and I happen to know that there's some pretty low overlap. So let's go, let's run that alignment. And once that's finished, you'll have your alignment there, hopefully, and you will be ready for meshing. So I'm just going to adjust this. I happen to know that I don't particularly want this stuff at the back here, so I'm just going to crop that out. And it's quite interesting actually. I'll just quickly show you. It hasn't figured out exactly where the camera positions are, but what you can see here is this is the Mars rover here, and it has a left and a right camera, and it just pivots on the spot. The rover takes a series of stereoscopic pairs that can be stitched together to recreate the view. Pivoting on the spot is not recommended when capturing a dataset for photogrammetry, but somehow this works as the position of the camera changes just enough, and it really helps having the stereo pairs. But if you are collecting data on Earth for RealityCapture, try to move between taking each photo, and don't pivot on the spot, even if you do have a stereo rig. There's my reconstruction region made up, and I'll just pull that in a bit there, and we can reconstruct in normal detail. So mesh model, and then actually one thing, I'm using version 1 of depth maps because I found out they work a little bit better with this. So you won't get the increased speed of the version 2 depth maps, but you get a slightly better mesh in this specific data set. But for most data, it doesn't make a lot of difference. You may as well just go for the faster ones. So let's mesh model, normal detail. And once you finish meshing, you should have a result that looks something like this. And as you can see, parts of the sky meshed. So we're going to use those labels to delete those triangles in the sky there. So Scene 3D Tools, then AI Classify, and Transfer Labels, and you'll get this warning. You were using an experimental feature, so just click OK. And you can see here that my bits of sky have been turned white here. If I unfold the component and the model classes and the classification, you can see there that the white stuff is class 2. So I can click that and then click select. And there's been a handy way to select all those triangles around the top of these cliffs here. Now I can combine that with selection using the lasso tool. If I hold down Control, it will add to the selection, so I can get all of those triangles there, and then just keep going around. I'm going to do a fairly crude job of this. I advise spending a bit longer and getting it right if you want it to look nice. Yeah, none of this is very useful. Get rid of all of that. Get rid of all these big triangles in the background here. And then there's ones underneath here as well. Those ones. Okay, so I'm going to filter those. Okay, I think I'm nearly there. There's some big triangles on the bottom. I'm going to try and get those with the advanced selection. So select advanced. I think that's a bit big. It's actually selected most of them. Let's just make it a little bit less. Let's change it to 50. Oh, that's got some in the middle there. We didn't want that. 100. Still too big, so maybe 200. Maybe. I think I was closer with 250, 240. And select. Okay, there we go. Let's filter those. And now let's try and get the marginal triangles. Hopefully that's got a lot of the rest. We'll filter those. And I think we're getting there. I think that's good enough. So I'm going to do a simplification on that. So Scene 3D Tools and Simplify tool, and 300,000 seems like a sensible amount. The original was 14.6, we're down to 14.3. You can see if you look, a lot of these triangles are just noise, so we don't need that much detail. Actually, let's make it 500,000. Okay, I think we're nearly ready to texture. So mesh model, unwrap, and we'll do fixed pixel size optimal unwrap with 8K textures. And that's finished running, so let's just check our texturing settings. We've done a geometric unwrap already. Incidentally, these unwrap parameters are ignored if you've already unwrapped your model, the ones in the color and texture settings. And we are using visibility-based texturing style, but we're using the geometry layer. We don't want to do that. We've got a special texturing layer. So that'll do the job. Let's texture. And there we go. We have Mars, which is quite exciting. There you go. It's beautiful, isn't it? And finally, I'd like to say a thank you to Arizona State University's Meteor Studio and NASA's Jet Propulsion Laboratory for all their help making this video. Thank you very much for watching, and goodbye.